Well, hey there, guys. Now, in this lesson, we are going to learn all about a special type of function known as a hybrid function. Now, if we have a look down here, this is what we call a hybrid function. And it looks a little bit funky, I'm not going to lie, it looks a little bit scary, but it really isn't. You see, this is just like sketching more than one function on the same set of axes. Alright, but what we're doing is we're restricting some domains and things like that, so therefore it passes the function test. Now, if you think back to the previous lesson, what is the function test? Well, the function test is that it must pass the vertical line test, right? So therefore, if we draw a vertical line through these through this relation, so like so, you can see here, for it to be a function, it can only pass through the relation once. So you can see it's passing through once here, so it passes. Yep, passes through once here, so it's still a function. Passes through. It looks like it passes through twice, but does it really? Well, you can see here that this one's coloured in, but this one's empty. So in fact, it really only exists here, so therefore it's still a function, isn't it? Because it only passes through once. And then we go through here, so therefore this relation here is actually a function, and like I said, it's a special type of function, which is a hybrid function. And we'll look at these in a bit more detail now. So before we do that though, let's have a look at how we can restrict functions to make them one-to-one relations. So if we have a look here, this isn't quite a one-to-one relation, alright? We can see here that it's another type because there's more than one x value that will give you the one y value. So let's have a look at this. What type of relation is it, right? Well, we can see here is going to be many x values, because you can see this, it's going to come up, many x values, there's one there, and there's one here, will give us the one y value. So therefore, many x values will give us the one y value, so it's therefore a many to one. Let's have a look now at how we can make it a one-to-one. Right, so if we were to split this graph, if we were to break it up into different sections, we could make it a one-to-one. Now, where's that special part that we're going to need to split it? Well, if we think about it, it's going to be at this turning point, isn't it? So let's have a think about this relation in particular, y equals x minus 2 squared, for example. Now, as we know, this is a many-to-one relation. We're going to break it up at this turning point to make it a one-to-one. So let's watch this in action. You can see here that I'm going to take it down and I'm going to split it up like you can see there. Alright, now don't look at this as being the one graph anymore. This here is one graph, and then this here is another graph. So it's an x minus 2 graph, but it's only existing from negative infinity to 2. That's the domain. That's it. That's our graph. And then we've got a totally different graph now, where it's once again an x minus 2 squared graph, but it only exists from 2 to infinity. So therefore, the domain of this one is negative infinity to 2, and then this one is 2 to infinity. And you can see by restricting the domain, we've now made that a one-to-one relation. As you can see here, it goes up, and it only touches the y-axis, or one x value will only give you one y value, because as you can see here, it's two different graphs. They're not the same anymore. Alright, so let's now have a look at hybrid functions, shall we? So hybrid functions, like I said, look like this. It's like two different rules sketched on the same axis. And this is how it's going to look when you actually see it as a rule. A hybrid function is a function which has different rules for different subsets of the domain. For example, the function at right is represented by, bang. That's how it looks. It looks crazy. There's no doubt about it. It looks crazy. But let's just have a think about what it all means. This here is f of x is equal to x plus 1 for any x value below 0. So for any x value below 0, you can see that the rule is x plus 1. But for any x value above 0, well, it's equal to x squared. So for any x value above 0, it's got an x squared graph. Let's have a think about that in a bit more detail. So from negative infinity to 0, that is any x value below 0, inclusive by the way, it has the x plus 1 graph. Now x plus 1 is a linear graph that's going to have a y-intercept of 1, as you can see, and of course an x-intercept of negative 1. So therefore you can see this here is an x plus 1 graph for anything below 0. But let's have a look at anything above 0. Well, as you can see by this part of the rule, anything above 0 follows the x squared graph. And of course it's not included here, and it's an x squared graph, so therefore it's a parabola. So you can see we've just sketched two graphs on the same set of axes and restricted the domains to get us something that looks like this. Looks crazy, but it really isn't. It's stuff that you've learnt before. Alright, so let's have a look at this even more in-depth one, but it's really not that much harder. You just got to break it down into separate sections. Okay. Now the first thing I recommend you do when sketching hybrid functions is this. what you want to do is you want to go through and have a look at the different domains that we want to sketch between. So you can see here that f of x is equal to x for anything below 0, x plus 1 for anything between 0 and 2, and 5 minus x for anything greater than 2. So let's have a think about the different sections of the domain. We can see anything below 0, so therefore 0 is going to be there. So we're going to draw a dotted line here. And we're going to sketch something, I'm not going to think about it just yet, but we're going to sketch something for anything below 0. The next one goes for between 0 and 2. So therefore we're going to put a dotted line along 2. And as you can see here, once again, we're going to be sketching a graph. Now let's not even worry about what it's going to look like, but we know we're going to sketch a certain type of graph for anything between these two dotted lines. And then the last one says 5 minus x for anything greater than or equal to 2. So therefore, of course, we're going to sketch another function over in this section. So it's kind of like we're breaking it up into 3 separate sections. Right, and then we can go through and we can actually go through and sketch them now. So let's have a think about sketching the one below 0. We'll just work from left to right. So for below 0, f of x is equal to x. Now, what's an f of x equal to x graph look like? Well, let's have a think about it. We always want to use the extreme part. So, of course, the 0 part will be an extreme because that's the very end. Right, so let's substitute in f of 0. So, therefore, make x equal to 0. So, you get x equals 0. Therefore, x is 0. So, therefore, it goes to the point 0, 0. And we'll put a dot there. Now, is it actually going to include that? Well, no, it's not. So, therefore, it's going to be an empty dot. All right. Let's think about another number below 0 because it says any x can be any value below 0. So any value below 0, well, let's just come up with, say, negative 2, right? Because we know that's below 0. So let's make x equal to negative 2 now. So you get x equals negative 2, so therefore you get f of negative 2. And instead of writing x, you write negative 2. So of course it goes to the point negative 2, negative 2. And we know that just continues on forever. So therefore we can just draw a straight line going through negative 2 with an arrow because it continues on forever. Great, I've now sketched the very first part of that function, haven't I? Let's now sketch the middle one, right? And that is x plus 1 for any x value between 0 and 2. So we're now following a different graph, which is an x plus 1 graph. Now, if we think about it, we know it's going to be linear as well, don't we? Because it's just got a power of 1 for the x. So let's do that. Anything, we'll sketch x plus 1 for between 0 and 2. Right, so the very first thing is we need to find out the two values that it's going to work between. Now, like I said before, always use the extremes of the domain, so that's 0 and 2 in this case, because we can then join the dots. So we'll substitute in x equals 0 for this one. So let's make x equals 0, so you get f of 0, which is 0 plus 1, which of course is 1. So therefore you get the coordinates 0, 1. And we'll plot that point. Now, if you see here, at x equals 0, it's actually included, so it's going to be a filled-in dot. Alright, now let's do x equals 2. So we'll make x equal to 2. So you get f of 2 is equal to 2 plus 1, which is 3. So you get the point 2, 3. And we'll plot that point as well. Now, as you can see here, because it's not got a line underneath, it's not included, it's therefore an empty dot. And we can, of course, now just join the lines like you can see here. Alright, so it's not really that much more difficult to what we've seen before. We've already first sketched the first part of this hybrid function. We've now just got this last little bit to do, and that's 5 minus x for any x value greater than 2. Alright, well, like I said, you need to just use the extremes of the domain. So let's make x equal to 2 first of all. Alright, so x is equal to 2 for this one. So we're going to go f of x is equal to 5 minus x. Well, f of 2 is 5 minus 2, which is 3. So therefore you get 2, 3. So we'll plot that point there at 2, 3. And actually we'll wait for that because you'll see something happen in a second. And then we'll just plot in any x value greater than 2. So we'll just make, say, x equal 5 because we know 5 is greater than 2. So we make f of 5 is equal to 0 because 5 minus 5 is 0. So you get 5, 0. Now, we know that the second graph, or the last graph, goes through the point 2, 3. And it's actually included, isn't it? Because any x value greater than 2, so or equal to 2. So therefore, we're going to make this one actually become, was a plain empty dot before, but now the point at 2, 3 for here is going to be a coloured in dot. All right, you can do that. Okay, and then from here, we're going to plot the 5, 0. So therefore, it's going to go all the way down through here, through the point 5, 0. And you can see like this. And once again, because it goes on forever, it's a arrow at the end there. And that, therefore, is a hybrid function. Okay, there's not much more to it. You just got to sketch each section separately. And then once you've done that, put it all together, and you've got a hybrid function. So let's now have a look at the domain and range of this function, shall we? Let's state the range first of all. Now, I'm going to just do that little like ruler test kind of thing, but it will look a little bit different right now. So we'll have a look at the range of this function. if we have a look, the highest value that you can see it goes to is 3, isn't it? The very highest value, right? And it comes down to here. Now, if we come down, it doesn't look like it goes through here, does it? But if we have a look over here, you can see it actually does go through here. So you can see it actually is continuous at this point. So therefore, this range, it does actually exist between 0 and 1 because of this value here. And then we continue on down forever. You can see here that the arrows continue on forever. So therefore, the range of this is going to be from negative infinity to 3, where 3 is inclusive because, of course, it's a filled-in dot. Alright, what's the domain going to be? Well, the domain goes forever from this direction. This part's included because of there and there, the coloured dot, and it continues on forever in that direction, so the domain is real. Okay, so there's a lot there going on in hybrid functions, but like always, please, if you do get stuck, come and see me, and you've just got to think about sketching different functions between separate domains, and it just makes it easy if you break it up into each individual domain and think about it in small parts rather than a really huge task to do from the outset. Alright, so of course, like always, best of luck.